Hey everyone, so welcome to today's video. So in this video, today we talk about that performance between loops and vectorization actually. So we already know that loops it's almost all the programming languages. So by default, we start to implementing loops whenever there is a repetitive operation. But when we work with a large number of iteration like millions of billions of rows using the for loop, it's a slight complication actually, so you might stuck for that hours and after that realize so that it won't work actually. So this is where implementing the vectorization in Python it's become a super crucial actually. So before that, what is vectorization actually? So vectorization is a technique implementing by the NumPy and so array operation on a data set actually. So in that, we'll be looking some of the use cases where we can easily replace that Python loops with vectorization, and this will help you save your time and become a more skillful in that Python language actually. So the first thing, I can just simply start with some finding the sum of numbers like that actually. So I can just start with let me type the code. Yeah, so I can just import the time and the start time equal to, I can just take the start time. I can just looping that 1.5 million numbers. So I just initialize the 0 and that 1.5 million numbers I can just loop it, and after that printing that sum of value. Let me type. So here is the thing. So in that, just simply I can do that. I can loop that 1.5 million numbers, and that's adding all those things, and I can just print the total, and finally I'm going to print that how much time will it take actually. So here is the thing, and in that part I'm going to run that since AI dot. All right. So that sum is some values we'll get, and that it taking that zero point 0.5 seconds actually. Obviously that 500 milliseconds actually. So the next thing we are going to check with the same technique in that vectorization actually. So that same thing, instead of for loop, I am just removing that, and after that I can just put it like that actually. So in that I'm going to import the numpy. NumPy. Yeah. All right. So I have a same 1.5 million. We don't need the for loop. So in that we can replace with that MP sum along with that just arrange the year range actually 1.5 million values. So if I run that, all right. Now you can see that zero point 0.1 actually. So vectorization took 18x less time actually to execute the compare with that iteration using that range function actually. So this is difference will become a more significant while we working with the pandas data frame actually. And the next thing, I can go with some mathematical operation on the data frame level. So basically, in data science level, while we working with the pandas data frame, where the developers use that loops create a new derived columns, and using that some mathematical operation. So in that, we will just easily do that loops replaced with that vectorization for such use cases actually. And so let me type the code. I can remove it, and so the first thing we need to create a some basic data frame actually. So here is my data frame, and in that I'm going to import that numpy as well, numpy as np. So now I'm just print data frame. So data frame dot shape actually, and speedy, yeah, hold on. All right. So now around 5 millions of rows with the four columns actually. So in that four columns should be a B, C, D, and 5 million rows. So in that for testing, I can put like just 5 lakhs records. So because it takes too much time to execute actually. So that's why. So in that, my first thing is we'll be create a new column that called ratio column to find the ratio of the column C and D actually. So D and C obviously. So in that first thing I can just loop the data frame and creating a ratio column actually. So let me type the code. All right. So here is my code. I just looped that whole data frame with the iter rows. So that I'm going to find that D and C. Along with that, I'm going to find the ratio actually. So we'll see how much time will it take. And so in that, I'm going to first initially we need to notice the time as well actually. So start time, and also it should be a end time actually. So and the finally we need to just print that start to end. We don't need that. Yeah. Oops. Import time. All right. So now it's done. So I can clear it out. So Python intelligence ci.py. So if I run that, we'll see for the 5 lakhs records how much time will it take for the this thing normal for loop. All right. So here is the output. So this script will it take 28 second point 7 actually. So at the same thing, so I can just remove that for loop and I can check with the vectorization. So how much time will it take actually? So I just put that like that, and so we have a data frame. So in that, so I can run the code. We'll see. All right. So here is the thing. There is a drastic difference, 28 second and 0.02 actually. We can see the significant improvement with the data frame actually. So the time taken by the vectorization operation, it's almost 1,000 times faster as compared to the loops in Python actually. So this is one thing. And the next thing, I can check with some if else statements on the data frame level actually. We implement lot of operation that require to use if else type logic actually. So we can easily to replace the logics with the vectorization operation in Python. So let's look actually. So in that I have a same data frame, and so in that I don't need that ratio. So I can put that some this logic actually. So I can just simply loop the, all the rows, and if row equal to 0, then it should be a index should be a e, and if it is about 25 or below 0, so there is a some basic calculation. It will be based on that actually. And let me run that actually. All right. So now it will be taking 41 second point 7 actually. So I'm just removing that this concept, that normal for loop thing, and along with that if statement. So I can just put that some vectorization technique over there. So let me run the code with that same logic. Run that code. Yeah, now it's time to take 0.04 actually. So the time taken by the vectorization operation, it says 600 times faster as compared to that Python loops with if else statement actually. So this is crazy, right? Because instead of for loop, so we can simply use this kind of vectorization technique. So it will be saving that lot of time in your script actually. And the next thing, we can go to some advanced section about that some machine learning, solving the machine learning or deep learning networks using that vectorization thing actually. So the deep learning requires to solve multiple complex equation that too for the million and the billions of rows actually. So running the loops to solve this equation is very slow, and vectorization is the optimal solution for this your script actually. All right. So in that machine learning wise, so I'm going to just creating a one array, that means a one kind of matrix. So I'm going to do that some matrix multiplication actually. So not a some basic matrix. It should be a large size of matrix. So that let me type the code, and so here is the code, and in that, so I just importing the time. I just creating a 5 million of array size actually, so I don't need that, so I can just put the 50,000s, and that array size should be a 1 5, and along with that 50,000s values actually, and the same as I can put it as a 50,000. So I don't need the total, so I can just multiply and also adding with the total actually. So how much of values actually inside that. So, and also finally I can calculate that all the time I can just print that time actually, so how much the script will it take actually. So if I run that script, let me run with a normal for loop. So the computation time should be a zero point 0.2, and so that zero point 0.2 milliseconds actually. And the same as I'm going to implement the same approach on that vectorization thing actually. So I can just remove that this whole for loop. I can just put that single thing actually. This is the thing, np dot and xmt actually. So in that it should be a result, right? So here is the thing. So that same as 50,000, and I can take in the time and the end time and the final. So if I run that, as you can see that computation time should be a zero point 0.0 seconds actually. That means a fraction of seconds with between the fraction of seconds. So that the mp dot implements the vectorization matrix multiplication in the backend. It is 165 times faster compared to that loop in Python actually. So conclusion is, as you can see the results actually, vectorization is a Python in super fast and should be a preferred over for loops whenever we are working with the large data sets actually. So if your data set is small, then you can go with this normal for loop. If your data set is very large, then you can go with that vectorization and start implementing it over time. Then you will be more comfortable with that, thinking along that lines and the vectorization of your codes actually. So this is what I want to share with you guys, and I hope you really like that video. And if you really like that video, please subscribe my channel for more videos like this in the future. Also, if you have any queries or comments, please leave them in the comment section below. I am happy to respond. We'll see you on the next video. Thank you. Bye.